Dear students, very good morning to everyone. So, we are going to start the vector again. This is the second lecture of the particular chapter. Okay. So, today we are going to discuss about the direction ratios and the relation between direction ratios and direction cosine. Okay. And also we are going to find the vector if the position vector of the end point of the particular vector is given. Okay. These things we are going to discuss. Okay. So, first of all we define what is direction ratios. Direction ratios. Okay. If suppose A comma B comma C are the real numbers such that L by A, or you can say A by L equal to B by M equal to C by N, where L, M, N are the direction cosine of a vector. Okay. Then A comma B comma C are called the direction ratios of the vector. Direction ratio of the vector. So, this is the definition of direction ratios. ABC are any real numbers such that A by L equal to B by M equal to C by N. That means these numbers are ratio with what? Direction cosine of a vector. Okay, direction cosine of a vector. Then you can say ABC are what? Direction ratios. Okay. So, A by L equal to some numbers, B by L equal to same number, C by N is equal to what? Same number. Okay. Now, we have get a relation like that if okay, suppose P is a point with coordinate x, y, z, and suppose OP is a vector. Okay, and it is called what? R vector. Then we know that R vector equal to what? X I cap plus Y j cap plus what? Z k cap. Yes or no? And if L M N are DCS of R vector, then what there are relation between X, Y, Z and L M N? We get X equal to what? LR, Y equal to what? MR, Z equal to what? NR. Yes, this type of relation we got already, we prove it. And finally what we get? We get the coordinate of the point P will be, क्या होगा? कोऑर्डिनेट x is replaced by LR, MR, NR. This is the coordinate of the point. That means if you know OP vector, that means you can know the that is called magnitude. Magnitude is equal to what? R. And if you know LMN, direction cosine of R vector, then you can easily write what? The coordinate of the point x, y, z. Yes or no? Now, from these two relation also, you see, from these two relation, what you will get? You will get x by L equal to R, y by m, or you can say x by L equal to y by m equal to z by n, okay, is equal to what? R. Yes or no? So here you see L, M, N, where L, M, N are what? Direction, that is direction cosine of what? R vector given. So by the definition of direction ratios, x, y, z, from here you can say x, y, z are the direction ratios of R vector. ठीक है? If L, M, N are direction cosine of R vector, then if this condition is satisfied, then x, y, z will be the direction ratios of R vector. Because of the definition. Definition क्या था? A by L equal to B by M equal to C by N. So sometimes what happen, it may be L by X, M by Y, N by Z, same meaning, ratio are same. Ratio will be at 1 by R होगा. तो एक ही बात है. So what we will do, we will declare that x, y, z are the direction ratio of R vector as per the definition of direction ratios. So what are the interesting things you observe? Very, very interesting, you see. So this is your R vector, okay. So from the vector, if any vector is given, from the vector, first observation is that you can find the direction, you can find the from first observation you can say that the coefficient of I, j and k, that is x, y, z are called direction ratio of the vector. As per from all this discussion we conclude that x, y, z is the direction ratio of R vector. So we can conclude that from the vector x, y, z are what? Direction ratios. Direction ratios. If I give a real example, that is suppose I cap minus 2j cap plus 3k cap. Suppose this is the vector, okay. So it representing a point 1 minus 2 3. So ये जो वेक्टर है उसका डायरेक्शन फ्रॉम फर्स्ट ऑब्जेक्ट उसका डायरेक्शन रेशियो क्या होगा? 1 होगा, -2 होगा, 3 होगा. These are the direction ratios. But you cannot find the direction cosine directly. We can apply the formula and can get the result, okay. Now how to get the direction ratios? See, suppose R vector is equal to what? X I cap plus y j cap plus z k cap, okay. This is the vector. From this you can conclude that x, y, z are what? Direction ratios. Next, if L, M, N are the DCS of R vector, then what is the relation you get? You get the relation, but then x is equal to what? LR, y equal to what? MR, and z equal to what? NR. Already you get, yes or no? From here you can write L equal to x by R and M equal to y by R and z equal to, N equal to z by R, okay. So from here you can write L equal to first component divided by R means what? Magnitude of R vector, and M equal to y by magnitude of R vector and N equal to z by magnitude of R vector, ठीक है. So if you know the vector, आपको अगर वेक्टर पता है, अगर वेक्टर दिया गया है और आपको कहा है फाइंड इट्स डायरेक्शन कोसाइन, तो यू कैन यूटिलाइज दिस पर्टिकुलर फॉर्मूला, ओके. बिकॉज आपके पास x रहेगा फ्रॉम द वेक्टर, y भी रहेगा, z भी रहेगा, एंड मैग्नीट्यूड ऑफ आर वेक्टर आप मैग्नीट्यूड लेके ये आर वेक्टर का मैग्नीट्यूड निकाल सकते हो, उसका मैग्नीट्यूड लेके मैग्नीट्यूड निकाल सकते हो. तो आप इसके बाद इसमें वैल्यू पुट करेंगे तो LMN आपका निकल जाएगी, ठीक है. सो दिस इज द very interesting results ultimately we get by using this. We can find the direction cosine of any vector. Direction cosine of what? Any vector. Hope you find what the vector if the position vector of the end point is given. Okay, suppose that A is a point and B is another point, and position vector of A is given what, a vector, and position vector of B is given what, b vector. Okay, now you have to find what a b vector. ये दोनों दिया गया है, आपको ए बी वेक्टर निकालना है. ठीक है, ना पोजीशन वेक्टर की बात जब आएगी तो इट विल बी विथ रेस्पेक्ट टू व्हाट, ओरिजिन. सो सपोज दिस इज ओरिजिन. ओके, oh this is origin. Okay, with respect to origin, position vector of A is what, a vector, so you can join it, and this is what, your a vector. Okay, this is your a vector, and position vector of B with respect to origin is b vector, so you join it. Okay, this is your b vector. Understood? Now you can apply the vector law of addition. Vector law of addition use करेंगे तो क्या होगा, this vector plus this vector have a resultant this vector. Okay, by vector law of addition you will get, that is a OA vector plus AB vector equal to what, OB vector. Yes or no? Then finally you can write AB vector. Your need is what, find AB vector. AB vector is equal to what, OB vector minus OA vector, and OB vector is equal to what, B vector, and OA vector is equal to what, A vector, and B vector is the position vector of what, position vector of what, point B. Okay, and A is the position vector of point A. That means what happened, from here we can get a relation, we conclude a relation that AB vector is equal to position vector of terminal point. This is called terminal point, position vector of terminal point minus position vector of initial point. So in this way you can find the particular vector. Okay, understood? So these are the some basic concept I have discussed today, and let us solve few questions and then you will get an idea. Okay, so first question is, find the direction cosine of the vector I cap minus j cap plus 2 k cap. दिस इज द वेक्टर. उसका क्या निकालना है आपको, डायरेक्शन कोसाइन निकालना है. ठीक है, सो लेट अस सपोज दैट आर वेक्टर इक्वल टू व्हाट, आई कैप माइनस जे कैप प्लस 2 k cap. तो यू हैव टू फाइंड मैग्नीट्यूड फर्स्ट. मैग्नीट्यूड इज इक्वल टू व्हाट, 1 प्लस माइनस 1 होल स्क्वायर क्या होगा, 1 प्लस 4, फाइनली व्हाट, √6. दिस इज योर आर मैग्नीट्यूड ऑफ आर वेक्टर. ओके, and let suppose LMN are the DCS of R vector. ठीक है, तो what is the formula, L equal to what, x by magnitude of R vector, जो हमने रिजल्ट दिया था आप लोगों को, डिस्कस किया है. what is x, x is equal to coefficient of I1 1/6 m equal to y by magnitude of R vector. y क्या है, -1 1/6 and n equal to z by magnitude of R vector, and what is your there is z is equal to 2/6. So finally therefore this is r क्या होगा, 1/6 -1/6 2/6. These are the direction cosine of the vector. आप उन लोगों को स्क्वायर करके देखो. इफ़ यू स्क्वायर इट, ये स्क्वायर करोगी तो स्क्वायर करने के बाद समथिंग √6 होगा, √6. ओके, आई एम सॉरी, √6. सो आफ्टर स्क्वायरिंग व्हाट हैपन, इफ यू स्क्वायर इट, ऐड इट, यू विल गेट 1. यू विल गेट द रिजल्ट व्हाट, 1. ठीक है, now very important note is that if L M N are the indices of a vector R vector, then we know that L square plus M square is equal to N square is equal to what? 1. ठीक है, ये हमें पता है, we know it. Now L I cap plus M j cap plus N k cap represent any unit vector. What is the reason? Reason is what? L I cap plus M j cap plus N k cap मैग्नीट्यूड, उसका मैग्नीट्यूड क्या है? L स्क्वायर प्लस M स्क्वायर प्लस N स्क्वायर equal to what? 1. Since the magnitude of the vector is what? 1, so it represent a unit vector. Why it represent any unit vector? Because L equal to what? Cos alpha, M equal to what? Cos beta, N equal to what? Cos gamma. Okay, sorry, cos gamma. Okay, what is alpha, beta and gamma for different vector? For different vector, suppose this is an R vector. If R vector is different, it is a variable, it represent many vectors. Okay, so R vector, suppose R vector is equal to 1, represent 1 minus 2, 1 minus I cap minus j cap plus k cap, ऐसा काफ़ी वेक्टर हो सकता है. So every vector will makes different angles with the coordinate axis. जितनी वेक्टर, अलग अलग वेक्टर ने क्या करेगा, अलग अलग एंगल करेगा. दैट्स वाई व्हाट हैपन, अल्फा इज नॉट फिक्स्ड, अल्फा इज डिफरेंट फॉर डिफरेंट वेक्टर, बीटा इज डिफरेंट फॉर डिफरेंट वेक्टर, गामा इज डिफरेंट फॉर डिफरेंट वेक्टर. फॉर दैट मीन्स फॉर डिफरेंट वेक्टर एल एम एन विल बी डिफरेंट. सो एवरी वेक्टर हैव ए डिफरेंट डायरेक्शन कोसाइन एंड देयरफॉर एल आई के प्लस एम जे के प्लस एन के जो वेक्टर निकलेगी, बिकॉज एल एम एन आर नॉट फिक्स्ड, इट इज़ ए वेरिएबल इन टर्म्स ऑफ फॉर डिफरेंट वेक्टर. अलग अलग वेक्टर के लिए इसका वैल्यू अलग अलग हो रहा है. सो इट इज़ नॉट ए कांस्टेंट क्वांटिटी, इट इज़ ए आर्बिट्री. इट इज़ आर्बिट्री. ओके, ये आर्बिट्री है. इसीलिए ये जो वन हुआ है फॉर एनी टाइप ऑफ डायरेक्शन कोसाइन, अल्टीमेटली इट रिप्रेजेंट मेनी टाइप ऑफ व्हाट यूनिट वेक्टर. For different L, M, N, it will be a different unit vector. That's why it represent any unit vector. तो अगर आपको क्वेश्चन आए, write any unit vector in the in a space, ये स्पेस में है, 3 डायमेंशन है तो ना, तो आपको अगर कहे व्हाट इज राइट एनी यूनिट वेक्टर इन स्पेस, यू कैन राइट आंसर इज एल आई के प्लस एम जे के प्लस एन के कैप, और यू कैन राइट कोस अल्फा आई के प्लस कोस बीटा जे के प्लस कोस गामा के कैप लिख सकते हो. एलिमेंट रिप्लेस करके, ये रिप्लेस करके भी लिख सकते हो. ठीक है. सो दिस इज द रिप्रेजेंटेशन ऑफ एनी यूनिट वेक्टर in what space, in what space. That's very important. To discuss about section formula. This type of section formula we already discussed in class 11 in 2-dimensional geometry, and it was like that. What that is, suppose AB is a line with coordinate x1 y1 or coordinate x2 y2 divided by a point proposed P in the ratio what m is to n. Then you can find the coordinate of this particular point which divide the line segment AB in the ratio m is to n internally. Okay, this type of results you got. The result क्या था, mx2 plus nx1 divided by m plus n, and what is y coordinate, my2 plus ny1 divided by m plus n. ठीक है. तो in vector also, that is, suppose this is your vector, AB is a vector. Okay, AB is a vector, and this vector is divided by the point P in the ratio what m is to n internally. Okay, and given that position vector of A is what, position vector of A is what, a vector with respect to origin, and position vector of B is what with respect to origin is what, B. Okay, and we are going to find the position vector of P which divide the vector AB in the ratio m is to n internally. ये जो पॉइंट P है उसका पोजीशन वेक्टर क्या होगा, that we are going to find. Suppose that the position vector of P is what, R vector. We do not know what is R vector. Our aim is to find what, R vector. It is given position vector of what, A is given, position vector of what, B is given, end point is given, and this point P divide the AB vector in the ratio what, m is to n, and what is the position vector of this particular point you are going to find it. Okay. Now here you see we have supposed that all the things I have written, that is a position vector of A is suppose A vector, position vector of B is suppose B vector, and let P divide every vector in the ratio m is to n internally. So P is to what? So P is to PV equal to what? M is to n. Yes or no? And finally you can write what a P vector by PV vector is equal to m by n. क्रॉस मल्टीप्लाई करने के बाद ये मिलेगा. ठीक है. नाउ व्हाट इज PV vector? PV vector means how to find the vector if you know there that is a position vector of the end points. Okay. We know that every vector is equal to how to find a vector, every vector. We know position vector of B minus position vector of A. Okay. Position vector of terminal point minus position vector of initial point. In this particular result you can find it. Okay. The same result we are going to use here. So m into PB vector means m into B vector, position vector of B minus position vector of P. Position vector of B क्या है? B vector. Position vector of P क्या है? R vector. Similarly P vector क्या होगा? Position vector of P minus position vector of what? A. Position vector of A is what? P is what? R, and position vector of A is what? A vector. Okay. And after calculation taking R vector common, and you will get this result. Okay. And from here you can write, that is you can find R vector is equal to what? R vector is equal to MB vector plus is n होगा, MB vector plus NA vector divided by what? M plus n. Okay. This is the finally the position vector of the point is given by this particular results. Okay. If you know the end point of the position vector, if you know the ratio, then you can find the position vector of that particular point which divide the vector AB in the ratio m is to n. If this is the division is internal, and if the division is external, what will happen? Division is external. For external division, I am not going to explain, just write the formula, external division. Okay. Then for this position vector of R vector is equal to what? MB vector minus NA vector divided by what? M minus n. Okay. This is your result. Okay. If the division is external, this is the particular result, and division is internal, then this is the particular result. Okay. And if suppose that P is the midpoint, what happened? This is your AB vector, right? This is your AB vector. Okay. And this is AB vector, this is divided by the point P in the ratio what? Equal ratio. Okay. M is to M. If I say M is to M, that means what happened? P will be the midpoint. Okay. So position vector of this is what? A. Position vector of this point is what? B. Okay. Then what is the position vector of the midpoint? Position vector of the midpoint. If P is the midpoint, then your ratio will be R vector is equal to M is to M होगा. ठीक है. तो M N के जगह में आप M लिख सकते हो. M into B vector plus N into A vector. Sorry, this is M divided by M plus N. Yes. And finally you take M common, then here twice M रहेगा. So it means B vector plus A vector E into M, and नीचे क्या होगा? Twice M होगा. तो M cancel, and the final result will be what? B vector plus A vector divided by what? 2. So very simple way you can find the position vector of the midpoint which divide the vector in equal ratio. Okay. कोई भी वेक्टर दिया जाएगा, उसका एंड पॉइंट का पोजीशन वेक्टर दिया जाएगा, मिड पॉइंट का पोजीशन वेक्टर निकालना है, तो यू हैव टू यूज directly the sum of the vector divided by sum of the position vector divided by 2. Okay, this is very simple. Now we are going to discuss about parallel vector and collinear vector. Very important. I have shown in some figure. You see, this is a vector A vector and this is a vector B vector, and both are parallel one. Okay, both are what? Parallel vectors. Okay. So similarly C and D, both the vector are in the same direction, and these are what? Opposite direction. But both are what? Parallel vectors. So parallel vectors are those vectors what happen? A vector is a multiple of something B vector. A vector is a scalar multiple of some b value. We do not know what is the magnitude of this vector and what is the magnitude of this vector. Okay, what is lambda? There is a and b, a vector and b vector are parallel vector. We can say that a vector is equal to what? Lambda into b vector. If this condition is satisfied, then we can say that two vector are what? Parallel. Okay. So here a vector is a some scalar multiple of b vector. Lambda is what? Non-zero square. It may be an integral number or maybe a fractional number, no issue. Okay. Okay. According to the length, according to the magnitude of the vector. Okay. So if we say, if we get one vector is the scalar multiple of other vector, then we can say that both the vector are parallel. Okay. Similarly, collinear vector. What is collinear vector? That means suppose consider AB is a vector and SC another vector. Okay. Both the vector are lies on same line. Both the vector are lies on same line. AB vector and SC vector lies on same line. When two vector lies on the same line, then they are called what? Collinear vector. Again, we can say there is both the vector can be parallel also. Okay, but lies on the same line, but they are parallel. Okay. So in such cases, again the same result of the parallel condition will be used. AB vector is equal to lambda into what? SC vector. What is lambda? Lambda is a non-zero scalar. Okay. And lambda may be suppose 1, 2, half, minus root 3, anything. It is a real number. Okay. So according to the there is a magnitude of the vector we can get. Okay. तो इसका मैग्नीट्यूड कितना होगा, इसका मैग्नीट्यूड कितना होगा, उस हिसाब से लैम्डा का वैल्यू आएगी. ठीक है. सो आई होप यू अंडरस्टैंड द कंडीशन, दिस कंडीशन एंड दैट कंडीशन आर सेम. पैरेलल वेक्टर का जो कंडीशन है और कोलिनियर वेक्टर का जो कंडीशन है ऑलमोस्ट सेम है, बट हेयर ओनली द केस इज दैट देयर विल बी अ कॉमन पॉइंट. दिस एबी वेक्टर एंड एसी वेक्टर में क्या है, ए इज द कॉमन पॉइंट एंड इन दिस केस व्हाट एवर यू विल नॉट गेट एनी कॉमन पॉइंट. दोनों अलग अलग वेक्टर है, कोई कॉमन पॉइंट नहीं है. ठीक है. So here AB vector, this is AB vector. Here also AB vector and BC vector are also collinear. You can say AB vector is equal to what? Lambda into what? BC vector. Okay. So why collinear? Because there is a common point. First AB and BC are what? Parallel. दोनों क्या है? Parallel है. और इसके बाद दोनों का क्या है? One end point is equal to others initial point. Okay. One terminal point is equal to others initial point. दोनों common होना चाहिए. जब common हो जाएगी तो क्या हो जाएगी? Both the vector lies on same line and we can say that they are collinear. Okay. Now how to express collinear vector in terms of component, that's important. Okay. So suppose that A is a vector. It is equal to what? Like that. A vector equal to suppose A1 I cap plus B1 j cap plus C1 k cap, and B vector equal to what? A2 I cap plus B2 j cap plus C2 k cap. Now A and B are collinear. A vector and B vector are what? Collinear suppose. So collinear का condition क्या है? A vector is equal to what? Lambda into what? B vector. Now what is A vector? You put A1 I cap plus B1 j cap plus C1 k cap, and it will be what? Lambda into A2 I cap, lambda into B2 j cap, lambda into C2 k cap. Okay. We know that two vectors are equal. When two vectors are equal, when their corresponding components are equal. So from here A1 equal to lambda A2, B1 equal to lambda B2, C1 equal to lambda C2. Since both the vectors are equal, corresponding components are what? Equal. Okay. From here you can write A1 by A2 equal to lambda and B1 by B2 equal to lambda, C1 by C2. So finally you can write A1 by A2 equal to B1 by B2 equal to C1 by C2. This is the condition. This is the condition that two particular what there is vector are collinear. What is the there is a particular relation A1 by A2 equal to what? B1 by B2 equal to what? C1 by C2. Okay. So here you see this particular result is very important. When their corresponding components are in ratios, then you can say that two vectors are collinear. Or this is the same condition for two vectors are parallel also. When two vectors are parallel, when corresponding components are equal. So same condition will be applied for parallel. Okay. Understood? So if two vectors asked you that show that these two vectors are collinear, you have to find their ratios, corresponding component का जो रेशियो निकालेंगे, रेशियो निकालने के बाद अगर इक्वल हो जाए तो you can say that the vector are what, collinear. Okay, find the vector question. The question is find the vector whose magnitude is 8 unit and which is in the direction of the vector. This very very important. Your vector is suppose that is let the vector is what, let the vector is a vector. Okay, and you are given what is given magnitude is what, 8. इसका magnitude क्या है, 8 है. And you have to find this vector in the direction of this. Means what, एक vector निकालने के लिए क्या चाहिए आपको, magnitude चाहिए and direction चाहिए. Okay, डायरेक्शन इज अलॉन्ग दिस वेक्टर. तो इस वेक्टर का डायरेक्शन कौन देगा, उसका यूनिट वेक्टर देगा. तो यूनिट वेक्टर निकालिए. यूनिट वेक्टर इन द डायरेक्शन ऑफ फाइव बाई कैप माइनस जे कैप प्लस 2 के कैप इज क्या होगा, द वेक्टर divided by its magnitude. Okay, and if you calculate, this is what 25 root over 25 plus 1 plus 1, that means कितना हो रहा है, 27, means it's 2k. Okay, 25 plus 1 mean 5 square plus 1 plus 4. Okay, एंड ये क्या है, 5 आई कैप माइनस जे कैप प्लस 2 के कैप. ठीक है, देन यू गेट 25 प्लस 5 30 एंड इज 5 आई कैप माइनस जे कैप प्लस 2 के कैप. यस, देयरफॉर रिक्वायर्ड वेक्टर इज देयरफॉर ए वेक्टर इक्वल टू व्हाट, 8 इंटू द डायरेक्शन 5 आई कैप माइनस जे कैप प्लस 2 के कैप डिवाइड बाई रूट ओवर 30. सो दिस इज योर रिक्वायर्ड वेक्टर. This is the second question. Second question is find the direction cosine of the vector joining the points A with points 1, 2, minus 3 and B minus 1, minus 2, minus 1. The coordinate of the 2 points are given. This is your vector. Okay, you have to find the direction cosine. Okay, 1, 2, minus 3 and B is a point. This vector is minus 1, minus 2, 1. Okay, the end points are given. So you have to find first the vector AB. How to find the vector AB? You know what is the position vector of this point I cap plus 2 j cap minus 3 k cap. What is the position vector of this? It is what, minus I cap minus 2 j cap plus k cap. Okay, so when you know the position vector of the end points, you can find the vector. So AB vector क्या होगा, AB vector equal to what, that is this is this minus this. Okay, this is suppose a B vector and this is suppose A vector. B vector क्या होगा, माइनस आई कैप माइनस 2 जे कैप प्लस के कैप. ओके, सिमिलरली ए वेक्टर क्या होगा, आई कैप प्लस 2 जे कैप माइनस 3 के कैप. तो ए बी वेक्टर इक्वल टू व्हाट, पोजीशन वेक्टर ऑफ दिस माइनस पोजीशन वेक्टर ऑफ दिस, मीन्स व्हाट, बी वेक्टर माइनस ए वेक्टर. तो बी वेक्टर माइनस ए वेक्टर क्या होगा, माइनस 1 आई कैप प्लस माइनस 2. Okay, minus 2 j cap plus 1 plus 3 k cap. I hope you understand. कैसे, this one minus this. Okay, this one minus this, this one minus this. Okay, finally what is the AB vector? AB vector equal to minus 2 I cap minus 4 j cap plus 4 k cap. This is your AB vector. मैग्नीट्यूड निकालो. AB vector का मैग्नीट्यूड क्या है, this is what, root over 4 plus 16 plus 16. ओके, फाइनली कितना होगा, 36 इक्वल टू व्हाट, 6. दिस इज AB वेक्टर. नाउ डायरेक्शन क्वेश्चन निकाल दैट लेट L M N R that is CS of AB vector. Understood? Therefore L equal to what, फॉर्मूला क्या था, हमें पता था फॉर्मूला क्या है, x by मैग्नीट्यूड ऑफ द वेक्टर. ओके, x by मैग्नीट्यूड ऑफ द वेक्टर आपको पता था, बिकॉज यू नो आर वेक्टर इक्वल टू व्हाट, xi cap plus yj cap plus zk cap. What is the direction cosine of the vector? X by magnitude of this, m means what, y by magnitude of this, and n means what, z by magnitude of what, r vector. Okay. So here L equal to what, magnitude x, x means what in this case, what, -2, and AB vector is equal to what, 6. Finally you get -1/3. What is m? Similarly m equal to what, y by AB vector, magnitude of AB vector is equal to what is y, y equal to -4/6 is equal to -2/3, and finally you get n equal to what, क्या मिलेगा, 4/6 equal to what, 2/3. So the direction cosine of the vector are DCS are -1/3, -2/3 and 2/3. Hope you understand. This is a simple question. So in this way you can solve the particular question. Now the third question is, show that the vectors I cap plus j cap plus k cap makes equal angles with ox, oy and oz. Means positive x axis, positive y axis and positive z axis के साथ क्या एंगल कर रहा है, इक्वल एंगल कर रहा है. ठीक है. So our main job is to find the angles of made by the vector with ox, oy and z, and we are going to prove that these are all equal. Okay. Alpha, beta and gamma are the angle made by I cap, j cap and k cap with what, ox, oy and z. We suppose that. Now our job is to prove that alpha equal to beta equal to what, gamma. Let us suppose that the vector is what, a vector. What is the magnitude? If you take magnitude you will get what, √3. Simple. Okay. So since angle is related to what, direction cosine, so let us find the direction cosine. Okay. DCS of a vector r क्या क्या होगा, L equal to what, component x का है, x क्या है, 1 है, 1/√3. Okay. What is m? M equal to what, y, y is what, 1, y by magnitude of the vector, this is y by √3 means 1/√3, and n equal to what, 1/√3 similarly. Okay. Therefore L equal to m equal to what, n. Since the vector makes alpha, beta and gamma angles with ox, oy and oz, what is the direction cosine? What is L? L equal to what, cos alpha, m equal to what, cos beta, n equal to what, cos gamma. Okay. So implies alpha equal to beta equal to what, gamma, hence proved. Okay. It means that this vector makes equal angles with the coordinate axis ox, oy and oz. ठीक है. So these are the few questions I have solved, and I hope you understand. There are more questions in your text, and let us try yourself to solve other questions. Okay. And this way I have finished this particular exercise. Okay. In the next class I will discuss about product of the vectors. There are two products, one is scalar product or called dot product, another is what, vector product. Okay. So these are the most important chapters. Majority of the questions asked from the scalar product and vector product. So the next class I will discuss about scalar product and vector product. Okay. Thank you. All the best.